All right, guys, I'm just going to do a quick review of Unit 1 material. Flip my camera this way. Our first key concept was the particle view of matter. That involved drawing particle diagrams, taking measurements, remembering to add that estimated digit, just one, between the markings that you can read for sure, understanding that precise data comes from precise instruments, so using the correct instrument like graduated cylinders versus beakers when it comes to measuring volume, and then being able to calculate our percent error. Then we talked about relating mass and volume, which we found out to be the word density. Also think about your particle spacing here. More dense the substance, the more tightly packed those particle spacings would be. Also, we learned in this section that when we graph something and it's a linear line, y equals mx plus b, that we found that we could get a direct proportion through our equations. Next, we talked about conversions. So being able to put scientific notation into our calculators correctly, either by using parentheses or by using that E button with the two capital E's. Also, being able to set up a T-chart and knowing what numbers go where and canceling out our units. In key concept 2, we talked about phase changes. Phase changes means switching from solid to liquid to gas, or backwards. That involved heat transfer. So heat transfer always occurs from something that's hot to something that's cold. Exothermic means that the heat will leave. Endothermic means that heat will be absorbed. Exothermic changes have a negative Q. So we also talked about specific heat capacity, Q equals MCAT. So exothermic changes would be negative and endothermic changes would be positive. Also, we talked about calorimetry, and we did a calorimetry lab where we mixed that hot metal into that cool water, and we could calculate what that metal was based on its specific heat capacity. Our next main concept in key concept 2 was phase diagrams. So where a phase diagram is pressure versus temperature on the graph, you need to know where your solid, liquid, and gas particle spacings are, and also all those phase changes that go with a solid to a liquid becoming melting, or a gas going back to a liquid becoming condensing, things like that. We also looked at dry ice here, and we found that a solid could go directly to a gas, and that was called sublimation, or to sublime. Our other kind was heating curves. So I have two here. In heating curves, you've got to either cool the substance off, or a heating curve heats it up. On a heating curve, we have a temperature over time graph. We have solid, then we have a melting phase that has no change in temperature due to that heat of fusion. Then we have an increase in temperature while that liquid heats up. Then we have another flat line called heat of vaporization, the heat that it takes to separate out those particles. And then at the end, we've got our gas. You can, from this graph, because the heat doesn't change as a substance changes state, we can find the boiling point and melting point of a substance using a heating curve. And then being able to do heat problems, knowing when to use Q equals MCAT, or whether to use mass times heat of fusion or mass times heat of vaporization, depending on what part of that heating curve you're at. That will tell you what equation you need to use. Then our last key concept was kinetic molecular theory. Okay, remember that kinetic means energy of motion. Molecular are those particles we've talked about, right? And so this is just the same concept, just written in a different way, because this one mostly just pertains to gases. So as gases gain energy, they move faster, right? So being able to relate that to particle diagrams, knowing that pressure means collisions. So remember, we drew arrows to represent their speed, and then we drew those arrows hitting the side of the container and bouncing off to show those collisions. Also, you should be able to do pressure conversions from atmospheres to torr to kilopascals, etc. Then we talked about properties of gases. So in properties of gases, we should know that pressure versus volume. As the volume is decreased, the pressure will go up. Those are an inverse relationship. Pressure versus temperature. As temperature increases, pressure will also increase because, again, there's more collisions with the container. As the amount of gas is increased, so will the pressure. That's why we inflate our tires. We add more gas. That's going to increase our tire pressure. And volume versus temperature. As temperature goes up, that will, in a piston, increase the volume, or in a balloon, or things like that. That led us to the gas laws. So in knowing those relationships, we came up with a mathematical way to relate pressure, volume, and temperature of two different scenarios. Just remember, when you do these math problems, your temperature must always be in Kelvin. So for every degree C, add 273. So that concludes our review for Unit 1.